All right, here we go. Well, welcome back to the Azure Podcast. This is episode number 382, being recorded on the 16th of June, 2021, with special guests Brandy Brown and Cheryl Manalo. I'm Sujit, and on Teams with me, I have Cynthia, and of course, our special guests, Cheryl and Brandy, and we're going to get to them in just a minute. But first, let's cover a few updates that we have this week on the Azure space. And Cynthia, I don't know about you, but I put a few in there. Do you have something before I cover the ones that I put in the show notes?
Please go ahead.
Okay. So one thing that was interesting is that we do have a West US 3 region that's come up, and in fact, Cheryl and Brandy might remember this from our hack that we did, because it showed up. This actually the region showed up when we were doing price analysis in for the various Spot VM prices, and we wondered what West US 3 was because it was an odd region. And now we know it was about to become online, and here it is. So WestGS 3, based out of Arizona, is now online and is available for availability zones and all the other good stuff out there. So definitely something to look forward to. And another thing that our listeners may be aware of, there's a lot of free services you get in Azure. I know when I set it up in Azure, I set up my free account, and you don't have to pay for some of the service, like app services gives you a lot of free websites you can use. I think you get some for storage, and now they've added a few more services that you can use for free. Azure Key Vault, MySQL, PostgreSQL. So there's more reasons. Logic Apps has a free tier now, and also the encoding feature of media services, which we should, Cynthia, we should go back and look at this because we started using this at one point to encode some of our podcast shows, but it would turn out to be too expensive. Now, if it's free, I'm gonna go back and take a look at it. So that's another update, and we'll of course put some of this in the show notes. And then the third one is something that I'm very kind of dear, close to my heart is IoT Edge, right, and monitoring of IoT. IoT is difficult to monitor because it's out there somewhere where connectivity is not good. So Azure Monitor has now released an IoT Edge module, and what you can do is you can deploy that module in your IoT Edge device, wherever that may be, and that will collect all the telemetry from all your IoT devices and then ship it out to Azure Monitor whenever there's connectivity available. And so this is probably the best approach for monitoring all of these IoT devices because it kind of brings all of your telemetry into one place, so you could watch it over there. So we'll put links to all this in the show notes right after this. Well, that's all I have for the news. So let's turn the mic over to our special guests, Brandy and Cheryl. Could you please introduce yourselves? Tell us what you do at Microsoft and what your passion is in the cloud computing space, and we'll take it from there.
Cheryl, do you want to go first?
Oh, sure. Thank you, Sujit and Cynthia, for having us here. I'm Cheryl Manalo. I'm based out of Switzerland, and I'm a software engineering lead for commercial software engineering.
And I'm Brandy Brown. I'm the TPM. Well, I'm a TPM within energy transport and travel. That's not right? Energy, travel, and transportation. And I am relatively new to cloud. Most of my experience has not been in cloud, but I'm getting brushed up very quick as a part of Microsoft.
And just for our listeners, could you explain what the acronym TPM means? They may not know what that means.
Program Manager.
Okay, and what does that entail?
That's a great question. So TPMs are relatively new, but essentially we help keep the project on track, make sure that we are clear about the requirements. So we kind of play a product owner role in some ways, but we also pick up some of the Scrum Master roles in a lot of ways. At least that's how it is here. It's not typically completely standardized across the board. So.
Great. So what have you been working on recently that you think you could share with our listeners?
Sure. So I think before I jump into the project, let me talk a little bit about the setup here. So we have what we call one CSE week. which is essentially a week that we've set aside, and we're very regimented about this. We don't have meetings, we don't do anything like that. And this is a time for us to get together and work on meaningful and impactful projects, things that, you know, we're passionate about or that do good in the world. It's also a time for us to connect with people we don't work with every day. And to do things we don't do every day. So for instance, you know, Sujit, we had a bunch of dev managers who don't always get to code all the time. So it was nice to see them get back into code and work together. And then I think it also, of course, gives us the opportunity to upskill and learn new technologies and things like that. And we definitely learned a lot in our project. Anything you want to expand on 1CSE week before I jump into the project itself?
Yeah, I just wanted to reiterate in what you said with regard to working on something else, something different, because normally we have longer projects or projects that take a lot more time with our customers. And I didn't mention that before. I'm also in the industry of energy, travel, and transportation. So our day-to-day work is actually coding together with a customer and having 1CSE week to do something else, work on a Hack for Good project is actually a great opportunity for us also to convene together in different teams, right? So there were people that normally do not work with each other, like Brandy and myself. We are in travel and transportation, but she as a technical program manager does not work with me as a dev lead because we have other assigned people, right?
Yep. I just want to add a couple of things there just for our listeners. So CSE is just the short form for Commercial Software Engineering, which is the team that at least Cheryl, Brandy, and myself are a part of. And that team works with customers to onboard them onto Azure, to come up with innovative solutions that we can onboard onto Azure. So having said that, Brandy, you wanted to explain something about this 1 week project that we did.
Yes, so I'm going to be a little bit annoying. And before I jump into the project, I got to explain a couple of things so we understand we all have the same frame of reference. So the first thing I want to talk about is Spot VMs. And so essentially what Spot VMs are is when Azure has extra capacity, they essentially allow you to use that extra capacity via Spot VMs. And so essentially when Azure needs that capacity back, they evict your VM and you go on and have a contingency plan at that point. And so Spot VMs come into play really deeply when we start talking about sustainability. So another thing I want to talk about is the EPA emission scopes. And so this is something I learned in this project. I'm like, what? And so in this project that we did for this 1CSE week, we really look to reduce scope 3 emissions. So just to give a little rundown of what the scopes are, the EPA has defined certain emission scopes. There's 3 of them as far as I know. The first one is more about direct, like Microsoft's direct consumption, which is like our facilities or how we, you know, our company vehicles, things like that. Scope 2 is more about personal consumption, so we'll kind of keep it moving on that one. Scope 3, which is again the one we were focused on, which is more about the indirect consumption, right? And so what this means is that our customers that utilize our data centers, they are indirectly leaving a carbon footprint, right? And so if we can create a system where we can mitigate that indirect emissions, that does great for the world, right? And so that's the setup. And so I think when we start talking about Spot VMs, I think the first question that comes to people's mind is like, is it really feasible to run like a production grade application on Spot VMs if they're like getting it evicted, you know, and with like, I think it's like 30 seconds notice. And so that's what our project essentially set out to prove, that like you can do this, and also to provide like a case study so that people can understand, you know, how it's done in certain scenarios and how we approached it and things like that. Anything else I should expand on or you want to talk about that? Obviously, we have to talk about the whole project, but
I'm really curious. You said that there's only a 30-second eviction notice. Are all VMs that you're using Spot VMs, or will this be like a combination of more perpetual things versus some that are like more burst-like that can go on Spot VMs? You probably will go into that, but that was the first question that came to mind after you mentioned it.
Yeah, that's a great question, and I think Cheryl can touch on that.
Yeah, sure. So it depends on the workload, right, and the scenario, and also the SLA. that our customers have. For Spot, the ideal types of workloads could be if you need lots of compute instances, like, for example, in high performance computing scenarios, big data analytics, or visual rendering applications, or if you have time box processing. So with batch processing jobs that finish after a specific time, so you don't have to worry about the Spot VMs getting evicted during processing. Sometimes they might, right? So there's no security in them not being evicted. And some scenarios could be dev test environments where you don't have a specific SLA as well. In some cases, it doesn't have to be all Spot, as you said, Cynthia. All Spot is maybe for specific workloads, that would be a fit. But for production workloads, you might want to think about having a mixture of on-demand VMs, and in addition to those, having Spot VMs.
So tell us more about how this particular, now that you've put the kind of backdrop on this, how did we approach this this project from a technical perspective? What did we set out to achieve, and what were some of the steps we took to get there?
Yeah, so first we wanted to detect the evictions, right? So we looked into strategies on how to, not really strategies, because there's one way of detecting evictions is to use the Schedule Events API in Azure. And basically this API is a metadata service in Azure that gives your application a time to prepare for a virtual machine maintenance. So evicting a Spot VM is like a maintenance, a scheduled maintenance, and you only have 30 seconds to react to that. And there are some constraints as well in calling the Schedule Events API. So it must be pulled. The VM will not get a push notification. The API is only accessible from within the VM, so you'd have to deploy something from into the VM to be able to call the Scheduled Events API. And then it has to be a scheduled job or a cron job because you just get a 30-second notice, right? So you have to pull the API every 30 seconds to be able to react to an eviction.
And Cheryl, typically, let's say you do get a notification that, hey, you're going to be evicted in 30 seconds. I mean, what should an application really do? What's the most efficient thing it can do in that short period of time, and still, not get itself into trouble?
Yeah, so there are several compensation strategies that you could think about. You could call from that. Once you get the eviction notice, right, and you know that the VM will get evicted, you could call from inside the VM an API outside the VM to be able to take a specific action. And the action could be, for example, to instantiate a new Spot VM that will most probably not get evicted. So you saw that as well, Sujit, in the project. There is a way of finding out what the probability is of a VM type to get evicted, right? Currently, it's not possible to be able to query that programmatically. But if you look into the region, because the probability depends on the region and the stock keeping unit, so the VM type, basically. If you can find a Spot VM that with a less probability to get evicted, then first of all, it could be that your workload can run for a longer time. And then you could maybe also change the VM type that you're running in case your VM gets evicted.
So in this case, you would kind of ping some master process, maybe running on a non-Spot VM, right? So let's say you have one VM that is is always going to be running. That's your good VM, and then you kind of have like some kind of a master-slave relationship. Is that what you're referring to, Cheryl?
Or yeah, that could be a possibility. Or you could also pull an external service like Azure Functions, for example, to take that action. And that's what we actually did in the project, without going into details yet with regard to how the workload scenario looked like.
Excellent.
Kind of going back to what Brandy was talking about earlier, how does using Spot VMs help with reducing emissions? Because I'm still using a VM that is running, albeit that it might be just sitting there if I didn't use it, but how am I actively reducing emissions?
I'm really glad that you asked this question because I forgot to touch on that. So yes, the way that it reduces carbon emissions is because it's requiring less hardware, right? And so if we don't utilize that extra space, then we're actually essentially using extra hardware when we could be utilizing the existing hardware. Does that make sense? Cheryl, anything you would add to that?
Yeah, explained perfectly.
Yeah, I mean, and the way that I also kind of tried to rationalize that is, obviously, if we don't use Spot VM, they're using regular VMs, right? At some point, Microsoft's going to say, oh, we're running out of space. We need to add some more VMs in this data center. And those new VMs are going to use more energy, right? So that eventuality has been delayed or does not have to happen, maybe, because we are making more effective use of the VMs that we already have in the data center. That's how I rationalize that part, Cynthia.
Yeah, the question is, does a VM really have to run an on-demand VMs with a specific SLA, right? So if it's just a dev test environment, could it potentially go down for a certain time frame? In some cases, maybe if you have a very strict SLA that you have to be online 99.99% of the time, that may be the case. But in some cases, it's not really necessary to run on on-demand VMs.
No,
What
Cheryl,
is
I remember.
the
Oh, sorry.
oh,
Go ahead, Cynthia.
what is the eviction process? Because I would assume there's like other packages and other things running on that specific VM that you would need to make your application work. So if I keep switching, how do I make sure that the environment is always the same, that I have all the things I need?
Yeah. There are several aspects to answer that question, right? So a VM could, for example, get deallocated, so you could restart it again, or it gets deleted, which means that you have to redeploy another VM. And if your process is automated with regard to deploying a specific job, for example, so if you think about a job running on a Spark cluster, a job could get redeployed if you have the necessary pipelines for it, the measures for it. And in the case of our project, for example, we worked with GitHub Actions and workflows. So basically, if a VM gets evicted, or the whole cluster even gets evicted, you could redeploy the whole cluster and rerun the job again. Now, that may not be the right way to go, right? Because first of all, if you redeploy the cluster, redeploy the job, then processing starts from the beginning. So depending on the configuration that you have, you could, for example, have a mixture of on-demand and Spot VMs, like I mentioned before. If that is the case, if the master node or the driver node is on an on-demand VM and your worker nodes are all Spot, then the master node or the driver node actually tracks the job completion, right? So you can redeploy VMs, even though you don't have any VMs anymore. You could redeploy another worker node or more than one worker node, and they would pick up the job again. So that could be one of the strategies, depending on the workload, right? So in the case of Spark, this is quite straightforward. You have a specific strategy to go forward with, but if everything's gets evicted, then you could basically redeploy again.
And Cheryl, I believe that the VMs themselves will have the same image, right? The image or the template that is used to deploy the VM will be the same. So when one gets deallocated or removed and another one is created, it's created almost identically to the one before. So all the software, Cynthia, like you were talking about, will already be there because they're part of the image. But as Cheryl was saying, it has to pick up from where it left off in terms of the processing. We don't want it to start all of the stuff because these are typically used for long running, maybe batch style or reporting style applications. And obviously you want to continue where you left off. And so there's got to be some sort of a checkpointing mechanism, I believe, right? Where you, as you're proceeding, you're saying, okay, I'm here, I'm here, I'm here. And if it gets deallocated, you continue from exactly that spot and not lose a whole lot of that compute that you just did.
Yeah, exactly. And if you automate everything, and that's what we aim to do, one of our projects really work with infrastructure as code, then you have the configuration that you can actually redeploy with ease.
I remember another kind of fascinating aspect of this was the pricing, right, for these Spot VMs. I mean, that's one of the, I know we're talking about reducing carbon emissions, but it also reduces the cost to your bottom line in Spot VMs, and there's significant cost savings, right, with these things. What can we expect in terms of the amount of cost savings with Spot VMs, for example? It's like 50%, 60% or more? Or, I believe it's at least 50%, if not more.
Yeah, it depends on the region, and then you found that out, Sujit, together with Olha, right? Because you worked on that. It depends on the region. So there are several regions where you can you can actually see the price difference of 40% or 50%, as you said. And some regions it could be less, right? And our official messaging as well from our documentation is that you could even save more if you're using reserved instances as well. So there's a potential saving of up to 90%, I believe. That's what we say in the documentation. Because what we looked at was basically the official pricing from the pricing API. And there you can already see that you can potentially save quite a lot.
Yeah. One thing we discovered is that the prices for Spot VMs is not static, right? I mean, it doesn't change within the week, but it basically, it's supposed to track how much capacity you have in the data center. Obviously, if there's less capacity, the Spot VM prices become more expensive. If there's more capacity, Spot VM prices become less. And so, as Cheryl was saying, different regions in the world have different capacities, right? Different data centers. And so if you really want to take advantage of this from a cost perspective, I suggest you look at some of the other regions out there. Like, for example, we found Australia East to be the cheapest for Spot VMs. I guess there was a capacity there at this moment of time, maybe not 2 weeks from now. So that was another kind of eye opener for me when it comes to Spot VMs. It's just that the variety of pricing.
How do you manage the IP addresses that will change when you get a different Spot VM? Or like from the security aspect, do you put everything behind some sort of load balancer so it just always goes there and you don't care about what's in your backend pool? Or how do you address that? And especially, I know you all mentioned that you want to prove that this is enterprise scale production ready, because that's definitely one thing that our enterprise customers will care a lot about.
Yeah, and I am not a networking expert. But luckily, we have managed services, right? So in the workload scenario that we looked into, it was a Spark workload. I mentioned that before already. You work with either Databricks or even within a vanilla Spot cluster running on virtual machine scale sets, right? So in the case of Databricks and also AKS, Kubernetes services, because they are managed services, the network configuration is basically handled by the service itself. And there are, particularly with Databricks, you don't have to think about that at all. because you have specific settings that control and how the system will react upon eviction. So you can choose a setting, for example, to replace a Spot VM in case it gets evicted with an on-demand VM. So you can get notified that it will be evicted, but you have the security that it will be replaced with an on-demand VM and that the processing can continue. Similar as well with regard to AKS, where you have node pools. So you can add an additional node pool running on Spot VMs, and basically the service will handle the networking configuration, and you don't have to do it by yourself. If I'd had to do it by myself, I had to look into it because, to be honest, I'm not sure.
Yeah, I mean it's a good question, Cynthia. Like when it comes to eviction, right? The one thing that we found out is that the pricing, there's almost like a marketplace for pricing, right? You can say, oh, I want to spend 10 cents an hour, right? And so you get the VM, and then the moment the price of the VM goes over 10 cents an hour, you get evicted. So that's one reason you get evicted, because you put a price that was too low, okay? Or you were very conservative in your pricing. On the other hand, what we found out with the Spark is you could say, always accept the highest price that the Spot VM will offer, right? So in which case, even if the price of the Spot VM increases a little bit, it'll still be nowhere near the price of an on-demand VM. You'll still be saving a lot of money, but it'll just keep on adjusting the price automatically. In which case, you're very unlikely to get evicted unless the data center is actually running very, very low on capacity, right? Which, we hope it never happens. So the chances of eviction are really on, on what you selected on the pricing, I think is one thing. And of course, if we do get evicted, then yeah, your question is dead on. Like, what do you do from the IP address perspective? I think that's a very valid question. I believe Cheryl's answer was perfect. It was managed services. You don't have to worry about it. But if you were to do this yourself, putting it behind a load balancer might be a good idea. Again, you still have to kind of, the workload, I would question the workload that you're using in that case, because you typically don't want to use it for a web server or something like that, because you don't want to get evicted in the middle of, serving web requests and things like that. So it's kind of more like in the non-interactive processes, right? Things that are running in batch or report generation is, I think what is the typical use case for things like that.
Yeah.
So you get to choose what VM that the managed service you're deploying is running on? Is that what I'm hearing? Like you can choose the underlying infrastructure?
Yeah, so you can choose the VM type, for example.
Okay.
And then there are settings to control. So the driver node, the master node, is always on an on-demand instance. So that will not get evicted because that node actually keeps track of the workload or the processing, right? So it keeps track of what tasks have been already processed, which jobs. But with regard to the Spot VMs being evicted, you can, with the settings, you can control what you'd like to have, right? If you say, for example, I think Spot availability on Azure, if you set that as a setting for availability, then you don't have to worry about your Spot VM being evicted because they get replaced by on-demand VMs. But this is a specific service that you're using, right? If you're using another service other than Databricks, then you might have to think about other strategies. You might want to, for example, restart an evicted VM, or if it gets deleted, provision another VM with another VM type, where you know that, okay, most probably this will run a little bit longer, or the probability for this VM type to get evicted is low.
Yeah, I mean, like in the case of Spark, for example, not all VM types are listed in the thing, because obviously it's a heavy duty application. They don't want you, putting a very small VM on that and then getting a very bad user experience, right? So they do limit, like in the case of Spark, they do limit the type of VMs that you could use, but it's a pretty big list, yeah. And that goes for Spot VMs as well. I don't believe all VM SKUs have like a Spot option. Most of them do. I must say that, but it's not 100% as far as I recall.
So is Spot VM only available for specific managed services? Like for instance, if I want to run app services right now, can I choose a Spot VM as our underlying infrastructure? Is that an option?
It's a good question. I don't know the answer to that question. I don't know if Cheryl or Brandy know.
Yeah, so definitely it depends on the Azure service if we support Spot VMs or not, right?
Okay,
so
got it.
with Databricks we do, with AKS Kubernetes services we do, for VM scale sets we do as well.
Okay.
But with
That
regard to
makes sense.
I'd also have to investigate.
Good question.
Yeah.
All right. So I guess Brandy, I mean, you want to say something about how the overall project was kind of run from a TPM perspective, and what were the outcomes of this engagement that we did?
It's a good question. Essentially, what happened was that Cheryl and I and another dev manager from my time zone, so that we didn't have the time zone disparity, we essentially got together before the project and kind of thought through, how we would approach it from a technical standpoint to prove this out, given because we only have a week, right? So we need to get all that up front. And so we came in with that kind of plan already in place for how we're going to implement. And so Cheryl had pulled out the EnergyNet project, which we can talk more about. I think Cheryl can give some color there, or you, Sujit. And essentially that was running on Databricks. So long story short, come to find out that at around the same time, Databricks did go GA with supporting Spot VMs. So the great thing is we proved that is resilient and it does work well. And so then from that point, we started to basically explore other options outside of Databricks to understand how it could be done without that service. Does that make sense?
Yeah, absolutely. So what we first, the EnergyNet project, we haven't explained that yet. So EnergyNet is a Danish company, energy company. And we have collaborated with them in a previous engagement, not my team, but another team. And as an outcome of that engagement, they published the Green Energy Hub as open source software on GitHub. And what they want to do with that is basically to create access to relevant data and insights from the energy market for other energy providers or operators. And we took a workload from the Green Energy Hub, and it was generalized by the previous team. And it's a Spark workload, as Brandi said, already running on Databricks. The business scenario behind that is basically an IoT scenario. So you have Danish households sending electricity metering data to Azure IoT Hub. And then that gets forwarded to Event Hub's Databricks, basically fetches the messages from Event Hub. So it's a Spark streaming scenario and pushes the messages and processes them, pushes them onto data lake, or in our case, it was a Delta Lake. And this was the scenario we worked on. We already had the let's say, preparation done by the previous CSE team with regard to generalizing the code that they wrote. So it was easier for us because we just had 1 week to work on it, to start from there. And then, as Brandi said, Databricks handles evictions quite well. We still tested eviction detection, right, and calling an external API. In our case, it was Azure Functions. And going forward from there, in the case of Databricks, you don't have to do a lot, right? You don't have to restart a VM because it's handled by the service. So what we did was to instantiate a vanilla Spark cluster running on VM scale set. And there we could actually choose, first of all, we could simulate the eviction, because you can actually do that with an Azure CLI. I know, Sajid, that you waited for a very long time for a VM to get evicted on Databricks, right? To test out the eviction notification, but it didn't happen in a short time frame. So the VM didn't get evicted, which is fine. But we wanted, because we didn't have that much time, for to simulate the eviction, and that was possible with the vanilla Spark cluster.
Awesome. This has been great. Thank you for sharing all those details of the project. And can we is it okay to share the repo for this with our listeners?
Yes, of course. We can share the outcome and the documentation as well.
Awesome. Very helpful. Cynthia, any last questions from you before we wrap up here?
No, this was awesome.
Thank you. Well, Brandy and Cheryl, thank you for giving us the insights into Spot VMs and how they can be used in a real world scenario. I think I know one takeaway I had from the project was that I think Spot VM should be considered for every project that you're working on. Obviously, not for time sensitive, but if it's not time sensitive, you certainly should consider Spot VMs from a pricing and from the energy consumption perspective. So, two good reasons why you should do that. Well, thanks again for
Thanks
all
for
your
having
insights.
us.
For having us.
Super
Thank
fun.
you.
Thank you.